Assalamualaikum, selamat sejahtera to everyone. I am Muhammad ZAMZURI from Kuliah of Allied Health Sciences, International Islamic University, Malaysia. Welcome to my presentation. Today, I will share a research finding about transfer learning based approach with deep convolutional neural network for COVID-19 detection. Here is the outline of my presentation. Bumi mana yang tidak ditimpa hujan? Nobody is perfect. Everyone makes mistakes, but it shouldn't be an excuse to keep doing mistakes. Misdiagnosis is common, but it can be a serious medical mistake. There's a three type common of patient misdiagnosis, whether it can be false positive, false negative, or delay in correctly diagnosing patient condition. COVID-19 was initially identified in late 2019. While most cases causes only mild symptoms, COVID-19 can cause difficulty in breathing, pneumonia, acute respiratory distress syndrome, and ultimately death. Globally, as of 8 August 2022, there has been more than 581 million confirmed cases of COVID-19 reported by WHO. From that figure, it caused 6.4 million deaths. This means the mortality rate for COVID-19 is about 1 out of 90 patients, which is quite high, and it is an evidence why we should take serious action on the COVID-19 patient management. Before we go further, let me explain the comparison of machine learning and deep learning with traditional programming. Most of us know and understand what traditional programming is all about. When we have input data and using an algorithm suitable for solving a particular problem, we get result or output data. While for machine learning and deep learning, the process was the other way around. Instead of getting the output data, we try to find the best algorithm that will reproduce the output data we know as accurately as possible. This slide shows how artificial intelligence, machine learning, and deep learning are related to each other. Machine learning is the subset of artificial intelligence. Deep learning is the subset of machine learning. This animation shows a pre-trained model with images of cars. Initially, the model was trained with millions of images of cars. When we perform the testing, the model will recognize the image of the car. The more images that we can use for training, it will improve image detection. But when we have less images, for example, only few thousand of images, then we could use transfer learning. Transfer learning is a process to reuse parameters that have been trained before. It implies transferring the pre-trained parameters to a different model. In the previous slide, I've shown you a pre-trained model to detect a car. When we use the same model and we add more parameters, the model now is able to recognize jet images. In our study, we try to answer this research question: how to achieve the optimal deep learning architecture for COVID-19 image classification. Now, let's move with the objective of the study. The study intends to evaluate the performance of deep learning architectures for digital chest X-ray images classification. Now, I will explain about the study methodology. We use chest X-ray image dataset consists of COVID-19 and normal chest X-ray images. We use 70% of the images for the training purpose and the rest of the images for the testing. We use 5 convolutional neural network in this study, including DARKNet 53, Inception version 3, Exception, Inception ResNet version 2, and ResNet 201. After we train the images, then we do the evaluation of the individual model for the testing images, and we perform the performance metrics for each individual models. Now we come to the slides on result and discussion. As we can see, the DARKNet 53 model has achieved the highest score for the accuracy and specificity. For the accuracy, it's achieved 98.4%. while for the specificity it scored 99.8%. On the other hand, ResNet 201 model scored the highest value for the sensitivity, which is 98%. In this table, we compare our finding with the other related study for image COVID-19 detection. This table also describes the methodology behind all the study. It can notice that our proposed models has achieved 98.4% accuracy, which is the best in all the reference study. In conclusion, the study has achieved 98.4% accuracy in classifying COVID-19 chest X-ray images by applying transfer learning. The pre-trained darknet 53 architecture shows in the study an excellent accuracy value. Our finding confirmed that deep learning can make the diagnostic process more comfortable as it can achieve human-level accuracy for image classification tasks. What is the implication of the study? First, deep learning can efficiently execute time-consuming tasks like detect symptoms of COVID-19 from the chest X-ray images, and this will be an excellent asset for doctors. Next, deep learning will play an impactful role in saving valuable life. It could improve patient care in terms of image diagnosis and also patient management. These are the references. That's all from me. Thank you for your kind attention, and I welcome questions from the audience.